Hey everyone, and welcome to Lab 11, which is going to be a walkthrough of the neural networks, part two. So instead of working on the different inputs today, hey everyone, and welcome to Lab 11. Today we're going to be continuing our exploration of neural networks, but instead of changing the inputs like we did before, we're going to be focusing on how we're changing the architecture and training algorithms impacts the performance. So let's walk through what you'll be doing and more importantly, what you should be paying attention to as you run these models. So again, in the first part here, you're going to be working through that setup. So you can download Neural Networks 2.m and you're just going to be CDing into your downloads. So going into that downloads folder, or you could just directly open up the MATLAB script in MATLAB. You're going to load and train the data. So there's going to be net2, and then that's going to have, again, 35 inputs. There's going to be one hidden layer with 25 units, and then 26 output units for each letter A through Z. After it finishes training, you can close the end-to-end train tool window, and this will be our baseline neural network for comparison. So part two is going to be where we're working into some of the deep networks and deep neural networks, which is net3, trained with two hidden layers, each with 25 units. And we're going to be comparing it against net2. So we're really asking, does adding a second layer improve our performance? And you're going to see the graph comparing the network training performance. And then you could look at the performance plot, which is going to show the mean squared error over the different iterations. And if net3 doesn't show a large improvement over net2, even with more layers, what might that say about the complexity of this task? A simple task like letter recognition may not actually benefit much from the depth because the patterns are relatively straightforward. So the next part is going to be comparing net2 and net3, training on basic statistics such as training time, number of iterations, and the final answer. So if net3 trains longer without much improvement, basically you'd be choosing net2. But if net3 shows lower error and better generalization on noisy data, then that might be the better choice. And then finally, in part three, you're going to be looking at the varying hidden layers here. So we're going to be testing net4, which still uses one hidden layer, but it's going to change over the number of hidden units. So you'll train this model. You're going to take a screenshot of the training window and record the number of hidden units. Note how long it's trained and how many iterations it took. So for part four, which is a little bit lower here. You're going to be testing net2 and net4 side by side to evaluate their error rates under increasing noise. And what's going to happen is you're going to see a bar graph or possibly a line graph show up that's going to be giving you the percentage of recognition errors across the different noise levels. And what you want to figure out is which network holds up better as noise increases. And does the larger hidden layer help resist noise or does it overfit it? And then again, finally, working with gradient descent again in part five, you'll be using the Levenberg-Marquardt for training so far. But now we're going to try a different version of gradient descent, which is going to train a little bit slower. It's going to use smaller steps to adjust the weights, and it might lead to better generalization on noisy data. So for this part, you're going to run that L2 gradient descent. I'm sorry, number 12 gradient descent. And again, take a screenshot of the window. Record the error and the number of iterations, and again, the performance plot. And what you're probably going to see with this one is that more iterations and slower training might be a result of this, but it might be similar or just a little bit better in the long run compared to the other models. So again, really what we're focusing on today is just kind of continuing with what we've been working on the past week or so with neural networks, and that it's not just based on the data, but by the actual architecture of the neural network as well that matters. If you have any questions, feel free to reach out to me ahead of lab. If not, I'll see you on Wednesday.